Example 3, we're looking at evaluating a trigonometric expression. Find the exact value of sine of u plus v, given that sine of u equals 4 over 5, where u is between 0 and pi over 2, and cosine of v is negative 12 over 13, where v is between pi over 2 and pi. So it's telling us what quadrant it's in. So let's start with sine of u, that is in quadrant 1, because it's between u is between 0 and pi over 2. So sine of u, so when you draw our triangle, this is opposite over hypotenuse. So opposite is 4, or y value is 4, and the hypotenuse is 5. And then for cosine of v, that is in quadrant 2 here. And so we know that negative 12, that is our x value, or the adjacent, over the hypotenuse, 13. So we are using, we do need to figure out what sine of u plus v is. And so we know that we need cosine u. We also need sine of v. That is what we're missing. So let us find cosine of u first of all. So to do that, I just need to find the missing value here. And remember that is the r squared, so 5 squared equals 4 squared minus x squared. So that's going to be the square root of 25 minus 16 equals x, or x equals square root of 9, which is 3. So this is 3. We therefore know that cosine of u is 3 over 5. So let's figure out cosine of v equals negative 12 over 13. So we need to find our y value. So this is 13 squared minus 12 squared equals, let's just say, our y value, square root. So y equals the square root. After you do all that, you find out that the square root of 25, 169 minus 144. So y is 5. So therefore we know that the sine of v is 5 over 13. And then sine is positive because it is in quadrant 2. So be careful of those signs there. Really important to draw your triangles. So now let's do sine of u plus v. So sine of u plus v is sine of u cosine v plus cosine u sine of v. Then we replace what we know. So sine of u we know is 4 over 5. Cosine v is negative 12 over 13 plus cosine of u, which is 3 over 5, times sine of v, which is 5 over 13. So one thing, just to look at patterns and things that are happening here, notice that we don't double use, we don't reuse any of the values in here. They're just used once. So now that we multiply, notice that the denominators are going to be the same. So 5 times 13, so that makes it really nice. So 5 times 13, that'll be 65, common denominator. And then 4 times negative 12 is negative 48, plus 5 times 3, which is 15. So we get negative 48 plus 15 over 65. That final answer is negative 33 over 65. So try the example here. Find the exact value of cosine of u plus v, given that sine of u is 12 over 13, where u is between 0 and pi over 2, and cosine of v is negative 3 over 5, where v is between 5 over 2 and pi. So trying this example out, they are pretty much the same numbers, so that probably made it a little faster. So cosine of u, you should have found that to be 5 over 13. Sine of v, you should have found that to be positive 4 over 5 using Pythagorean theorem. So cosine of u plus v, you would get cosine u cosine v minus sine of u sine of v, and then you plug everything in, you would get negative 63 over 65. Let's do an application of the sum formula. We're going to write cosine arctangent of 1 plus arccosine of x as an algebraic expression. So when you see cosine and there's no variable here, notice that it's this. So we're looking at cosine of u plus v, and so we have to use a sum formula for that. So we have to first look at the arctangent of 1 and remembering what does that look like. So arctangent of 1, so that's opposite over adjacent, so that's 1 over 1. Then we know that this value here, the hypotenuse, is 2. Then arc cosine of x, we know that that is x over 1, so that's adjacent over hypotenuse. Our hypotenuse is 1, and the adjacent value is x. So we need to figure out what y is. And so to figure out y, that's just the 1 squared minus x squared, and the square root of that will be y. So our y value is actually the square root of 1 minus x squared. So now we have this information. Now we can do this cosine. Arctangent of 1 plus arc cosine of x. So we remember that the cosine of u plus v is, so this is our u and this is our v. So this is going to be cosine of arc tangent of 1 times cosine of arc cosine of x, and then minus sine of arc tangent of 1 times sine of arc cosine of x. So we're looking at the cosine of arctangent of 1, so we're just looking at this triangle here. So the cosine here is adjacent over the hypotenuse, so that's 1 over root 2, or we can just say that's root 2 over 2. That'll save us in rationalizing the denominator later. Cosine of arc cosine of x, so arc cosine of x, we're looking at this triangle here. So cosine of arc cosine of x, that's just x, right? Because that cancels each other out. They're inverses of each other. And then minus sine of the arctangent of 1. So arctangent of 1, we're looking at this one, sine. That is opposite over hypotenuse, which is 1 over root 2, or root 2 over 2, right? So 1 over root 2, you rationalize the denominator. So that's why it's root 2 over 2. Then the sine of arc cosine of x, so that is opposite, so that's square root of 1 minus x squared over the hypotenuse of 1. Okay, so let's simplify this a little bit more. And so this becomes square root of 2x, and I have the common denominator of 2, so I know I can put it all together, minus, let's multiply this through, this is the square root of 2 minus 2x squared, all over the common denominator of 2. So try this example. Write sine arctangent of 1 plus arc cosine of x as an algebraic expression. So we tried this out. It's very similar to the last one. Actually, it's the same exact triangles. You could use that. But we're using sine of u plus v. So using sine of arctangent of 1 times cosine of arc cosine of x plus cosine of arctangent of 1 and sine of arc cosine of x. Then you find your final answer is square root of 2x plus square root of 2 minus 2x squared all over 2.